Okay, hello, welcome to my channel. In this video, we are going to give some basic properties of linear transformation. So, let me give the theorem here. Let's see. Oh, sorry. So here we have properties of linear transformation. Okay, then we have a theorem here. So let V1 and V2 be two-vector space and then we have a function from T to V1 to V2 is a linear transformation then we have the first property. So if we have T0 V1, this is equal to T0 this is equal to 0 V2, 0 V2. So this is the 0 in the V2. Okay, and then if we have T and here we have minus V, this is equal to minus TV. This is for all V in V1. Okay, and then if we have T, U minus V, okay, is equal to TU, okay. So this is equal to TU minus TV, okay, and then this is for all U and V in V1. And fourth property we have T, this is a K1 V1, okay, plus K2 V2 plus the plus K2 Vn. This is equal to K1 TV1 plus the this is Kn, right? Kn TVn. Okay, so let's prove this theorem. Okay, so proof. Okay, for the number 1, so here we have, okay, so in here by definition, okay, so I will put here by definition. This is definition of property 2, right? Okay, so this is property 2. Then we have here we have t, okay, k u, okay, this is equal to k and t u, okay. For k, this is in the field F, and also u in the vector space V1, okay. And then we need to set k is equal to 0 because k is any scalar number, right? And then here we have t, 0 times u, okay. This is equal to 0 times tu, okay. And then we know that t 0 times u is equal to 0, right? So here we have t 0, but 0, this is in the V1, okay. And this is equal to 0 in the V2. Okay, so number one proof, okay. And then we go to number 2. Similar to number 1, we have by definition, okay. This is property 2. Property number 2, and then we have similar, right? So we can set, right? Let's see, can put here, okay, set k is equal to -1. Then if we have t -1, okay, times u, this is equal to -1 t u, okay. So this is for u in the V1, okay. This is we can see this is equal to -1 t u, and number 2 proof. Number 2 is proof, okay. So let's move to number 3. Okay, so for number 3, in here we have t u minus v, okay. This is equal to t u, okay, plus -1 v, okay. And then by definition, we have t u plus -1 t v, right? And then by second property, I mean the second part of this theorem, so we have tu minus t v, and number 3 is proof, okay. So let's move to part 4. Okay, for the part 4, we will prove by induction. So we need to prove for the first one. So for n equal to 1, then we have t here, let's see, use k, right? Okay, t k1 v1, this is equal to k1 t v okay, let's see, t v1, okay. This is by definition. So for n equal to 1 is true, okay. This is true. Okay, so next we need to prove for n is equal to 2. So we have t k1 v1 plus k2 v2. Okay, so since we know from the property of from by definition, right? By definition 1, we have t k1 v1 plus t k2 v2, and then here by definition also we have k1 t v1, okay, plus k2 t v2, okay, and then this is also true. Okay, so let's move for n is equal to k. For n is equal to k, we assume the result is true. Okay, we assume that the result is true. So then here we have t. Okay, maybe I can use s, right, rather than k, because we have k here. Okay, I will change to s. So here we have t. Okay, wait, I need to use yellow here. We have k1 v1 plus plus ks vs. Okay, this is equal to k1 t v1, okay, plus plus ks t vs. Okay, so then we need to solve for n is equal to s plus 1. Okay, so here we have t k1 v1 plus plus ks vs. Okay, this is plus ks plus 1 vs plus 1. Okay, so we already assume that this one is true. So then we have, this is equal to k1 t v1 plus okay, and so okay, wait, so this is for example this is the first part. So by definition we can write as t, okay, q1 v1 plus plus ks vs, okay, plus t, this is ks plus 1, and this is vs plus 1. Okay, by assumption we know that this is true, so this is equal to k t, and this is v1 plus okay, plus ks t vs. This is by assumption before. Okay, and then for this part we use by definition, right? By definition, and then we have k s plus 1 v as plus 1. And sorry, this is we have t, and this is true. So this theorem are proof. Okay, thank you for watching.